Okay, boys and girls, in this video, we're going to look at graphing rational functions. We're going to identify the important parts of the function, graph them, and then graph on the desmos to fill in the rest of it. So here's some things that we need to remember. To find the domain of a function, we set the denominator not equal to 0. So the domain of this first function is going to be x plus 1 is not equal to let's get some pencils here, sorry. It's going to be x plus 1 is not equal to 0, which means x is not equal to 1, negative 1. So the way I would write that in interval notation would be my domain is all real numbers except for 1. And we write it that way. Okay? So it's all real numbers except for 1. My x-intercept, I set the numerator equal to 0. So to find the x-intercept, I'll have x plus 3 is equal to 0. So I get x is equal to negative 3. It's an ordered pair, though, so when x is negative 3, y is 0. So I'm just going to kind of graph that on the graph, and we get x is negative 3 is our x-intercept. That means that the graph will cross at x equals negative 3. My y-intercept, I make all of my x's zeros. So my y-intercept, I'll have y is equal to 0 plus 3 over 0 plus 1, which is 3. And so my x's were 0, my y is 3. So it's an ordered pair, and I'm going to graph that on the... Now, holes happen when something factors out. Nothing factored out, so there are no holes. My vertical asymptote happens when my denominator is equal to 0. My vertical asymptote and my domain will correspond. So x plus 1 equals 0, so we get x is equal to negative 1. We always write our vertical asymptote and our horizontal asymptote as equations. So what does that mean? The graph will never ever touch negative 1. It's like a wall. A vertical asymptote is like a wall that you cannot penetrate. So the graph will never touch x equals negative 1. Our horizontal asymptote, that's the one that's kind of a little bit more difficult to find. It's not difficult, but it just, you have to remember some things. So what we want to look at is the highest exponent in the numerator, which is x, the highest exponent in the denominator, which is also x. Because they have the same degree in the top and the bottom, the degree are the same, we're going to compare the coefficients. So since both coefficients is 1, our horizontal asymptote is 1. And that means that as x goes to negative infinity and x goes to positive infinity, the graph goes towards 1. You can cross a horizontal asymptote, but it just means that as you go towards infinity, it's going to gravitate back towards that horizontal asymptote. All right, so now that we have that, what we're going to do is we're going to go to our handy-dandy desmos, and we're going to graph that in desmos. When in doubt, in desmos, put parentheses. So since we have to divide by the quantity x plus 1 into the quantity x plus 3, we're going to need, I don't know what happened there, we're going to need a parenthesis. So then we have x plus 1. And I made a mistake because I don't know what I did here. Let's get rid of that. There we go. All right. So we can see from our graph that it crosses the x-axis at negative 3, crosses the y-axis at 1, and that it's hovering around 1 on both sides, and that it never crosses negative 3. So now I'm going to get a different color, and I want to draw my graph. Okay. So I see that it crossed the x-axis and then it just kind of hovered. That. And then on the other side, it crossed the y-axis and then it hovered around 1. So when you're graphing this, what I'm looking for is that it mirrors this, but also it's not crossing your vertical asymptote, that you're showing me where it crosses the x and the y axis. Those are the kind of things that I look for when we're graphing this. All right, let's do another example. So our domain, remember our domain, we set our denominator not equal to 0. So our domain is x, and let's go ahead and factor that. Let's make this 5 minus x over x plus 1, x minus 1. Okay, so my domain is x is not equal to 1. I should probably say negative 1. And x is not equal to positive 1. So how do I write that in interval notation? I'm going from negative infinity to negative 1, union. Then I'm going from negative 1 to 1, union. And then I'm going from 1 to infinity. Okay? And so what we're seeing is that every number except for negative 1 and 1 is represented. My x-intercepts, I set the numerator equal to 0. And I get x equals 5. Remember, it's an intercept, so I have to write it as an order paired, 5, 0. I'll just put that there. My y-intercept, I make all my x's 0, so I'm going to have y is equal to 5 minus 0 over 0 minus 1, or 0 squared, but it's still 0. So 5 divided by negative 1, my y-intercept is negative 5, and I write that as an order pair, 0, negative 5. So we go down here and we put that. Again, nothing factored out, so there are no holes. My vertical asymptote. Okay, so if anything cancels out, it can't be both a vertical asymptote and a hole. But since nothing cancels out, I'm going to have two vertical asymptotes. One, because I have x is equal to negative 1, and I have x is equal to 1 by setting the denominator equal to 0. Okay? So those are my two vertical asymptotes. And again, I'm just going to sketch them. So at negative 1 and at 1. And my horizontal asymptote, I compare the exponent in the numerator, the highest exponent in the numerator, x to the first, and the highest exponent in the denominator, which is x squared. And because the top is bigger than the bottom, the bottom is bigger than the top, it's bottom heavy, then there is then the horizontal asymptote is y equals 0. So when the denominator in the bottom is bigger than the denominator at the top, then the horizontal asymptote is y equals 0. So we sketch that like that. All righty? So now we're going to graph it to see what we got. So let's get rid of what we have there. And this is parenthesis 5 minus x divided by x squared minus 1. Okay, that's a little different, but that's just what we have. But notice how it's corresponding to what we have. We have an x-intercept at 5. There's a y-intercept at negative 5. And we see our horizontal asymptotes and vertical asymptotes. So let's just kind of graph that. I'm going to get another pen again. Let's go back to red. And so we never cross the y-axis. So it kind of just goes like this. But on the other side, we do cross the y-axis. The x-axis, but it still kind of hovers. Let me move this over a little bit so you can see, because it's still hovering over this axis. Even though it crossed it, it still hovers around it. And then on the bottom, we have that little thing in the middle. Okay? All righty, let's do the next one. All righty. Okay, this one, we're going to have a hole this time. Good. All righty. So the way we would do this, our domain, again, is let's go ahead and factor this. We have x plus 3, and then x plus 3, x minus 3. So our domain is x is not equal to, let's see, x plus 3 is not equal to 0, and x minus 3 is not equal to 0. So that gives us x is not equal to -3, and x is not equal to 3. So my the way I would write that in interval notation would go from -infinity to -3. We always start at the smaller one, union, -3 to the larger one, union, and then from 3 to infinity. What are my x-intercepts? Okay. Notice that x plus 3 cancels. So it cannot be both an x-intercept and a whole, because my whole here is going to be x plus 3 is equal to 0, so I have a whole at x equals -3. So something cannot be both a whole and an x-intercept. So after I factor that, this function looks like 1 over x minus 3. And so that's what we have to look at. And if it's 1 minus x minus 3, we set the denominator equal to 0, and 1 is never equal to 0, so there is no horizontal, no x-intercept. My y-intercept, again, we ignore the part that cancels out. So my y-intercept, I'm going to make x 0 again. I have 1 minus 3, so my y-intercept is -1/3. Writing that as an ordered pair would be 0, -1/3. Because remember, it's xy. We already talked about we have a whole at -3, but we have to see what is the value of that whole at -3. And to see that, we go back to the factored equation, and we put in -3 into the factored equation. So we're going to go back to the equation, 1 over x minus 3, the simplified expression, and then we substitute in -3 for x. So my whole is going to be at 1 over -3 minus 3, which is -1/6. That's the y value. So my whole is going to be at x is -3 and y is -1/6. Okay? So let's go back and graph our y-intercept. Our y-intercept is at -1/3, so it's like somewhere in here. My whole is at -3 and -1/6, so we're going to estimate that it's going to be somewhere in here. I'm going to say it's going to be above where I put the, somewhere in there. I can't really tell. We're estimating this. These are not accurate. Our vertical asymptote, again, the exponent at the bottom is bigger. So if we look at it, we have x over x squared. So since 2 is bigger than 1, the horizontal asymptote is 0. So if the exponent at the bottom is bigger, the horizontal asymptote is 0. Why did I put it there? I don't know. And then our vertical asymptote, we have to look at, let's see if I can get an eraser there. Our vertical asymptote, we have to look at where the denominator is 0. But remember, it can't be both a whole and a vertical asymptote. So 1 over x plus 3 is not a vertical asymptote because it's a whole. So I only have to look at 1 over x minus 3. So x minus 3 equal to 0. I get a vertical asymptote at x equals 3. All righty, let's put it all together. That one was a little confusing. So we have a horizontal asymptote at 0. There is no x-intercept, and we have a vertical asymptote at 3. And when we graph it, we can always check our work when we graph. So, and just a word for you, the graph will never show you the whole. The graph will not show you the whole. So we have to do x plus 3, and I would graph it the way that it is in case I made a mistake in factoring. That'll show up here. Okay? Whoa, I don't know what that is. Okay. X squared minus 9. Okay? And that's what we have. So again, the graph will not show you the whole. So what do we have? We have this hole here. And for the hole, we need to just kind of put a little open circle because it's not part of the graph. So it's come, and then it goes down. Oh, that's horrible. And then on the other side, we have a y-intercept of, there was no x-intercept. So then it looks like this on the other side. Okay? All right, last one. We have x squared minus 25 over x plus 5, our domain. X is not equal to negative 5. Okay, so my domain, negative infinity to negative 5, negative 5 to infinity. And if I go ahead and factor that, because I'm going to need to factor in a second, I see that x plus 5 cancels, so that's going to be my whole. My x-intercept, I don't need to look at my whole. I'm only going to look at x minus 5. So x is equal to 5, and we write that again as 5 comma 0. My y-intercept, I set my x is equal to 0. So I have 0 minus 25 over 0 plus 5. So my y-intercept is negative 5. And is that a whole? So I get negative 5. There is no the y-intercept here is also negative 5. Because when that cancels out, I put in 0 for x, and I get negative 5, so my y-intercept is negative 5, so that is 0, negative 5. Sorry, had a little brain fart there. I do have a whole this time, so I have a whole at x plus 5, which my whole actually happens at x equals negative 5. That should be positive 5. We'll see in a second. That's why we graph it to see. All right, so our whole is at x equals negative 5. No, there's two different points. This is negative 5. I'm sorry, I'm just struggling here. This is a y value. This is an x value. So we have a whole at x equals negative 5, and to find the y coordinate of that whole, we go back to the factored equation. So that's going to be negative 5 minus 5, negative 10. So my whole is at negative 5, negative 10, which we cannot show on this graph. We do not have a vertical asymptote because once we factor it, there's no denominator. And we have no horizontal asymptote because we have x squared on the top and x on the bottom. So if it's top heavy, there is no horizontal asymptote. Okay? Now this graph is going to look weird. It's going to look like a linear function, if you will. So let's graph it and see. And that's all that we know about it. It's just that where it crosses the x-axis. So we have x squared minus 5 divided by x plus 5. Okay. And I did that wrong because it's x squared minus 25. There we go. All right, see how it looks like a linear function? Because when we cancel everything out, we're just left with x minus 5. So our simplified function of that is x minus 5, which is just a linear function. So what does that look like? X minus 5, we have 5 as a y-intercept, which is what we got after some thought. And we have a line. And then when it goes to -5, we have a hole at -5, -10. Let's say if we represented that, that would be a hole here. And it would look like that. And again, the holes will not be represented on your graph, on your desmos graph or your calculator graph. You just have to know that it's there. All right, boys and girls, that's all we have for graphing this. Thank you, and I will see you tomorrow.